electromotive force and formula to calculate EMF and some problems. You have learned that cell is formed by two electrodes with different reduction potential values. What happens when two electrodes are connected and the circuit is complete? Electrons move from anode to cathode. Look at in the diagram, electron starts moving from anode to cathode. Why does this happens? Because there is a potential difference between two electrodes. Between anode and cathode, there is a potential difference. That's why electron starts flowing. With that, we are defining cell potential. The cell potential is the difference between the electrode potential, that is reduction potential of the cathode and anode. What is meant by electromotive force, that is EMF? EMF is when no current is drawn from the cell potential is called as electromotive force. So, when cell potential is called as electromotive force, when no current is drawn from the cell, then cell potential is called as EMF or electromotive force. For a cell, we can write the cell reaction as left side we should write oxidation which is taking place at anode M1 oxidized to M1N plus, and at the right side we should write reduction which is taking place at cathode M2N plus undergoes reduction into M2, and we should write salt bridge also. EMF of a cell. So how to calculate EMF of the cell? We can take EMF of the cell as cell potential or E cell. For the calculation purpose, we take EMF of the cell and cell potential as same thing. E cell is equals to E right minus E left. What is the meaning of this one? E right means electrode potential of right hand side electrode minus E left. E left means it is the electrode potential of left hand side electrode. So cell potential E cell is equals to E of cathode minus E of anode. So we are writing cell potential as E cell is equals to E cathode minus E anode. Under standard condition, the standard EMF of the cell is standard EMF. It is given by E naught of cell is equals to E naught of cathode minus E naught of anode. Now we take the difference between cell potential and EMF. There is a slight difference between cell potential and EMF, and also we have some confusion between cell potential and EMF. Sometimes students get confused with cell potential and EMF, so we will get clarification from this differences. First, cell potential. It is the potential difference between two electrodes, that is cathode and anode, in the cell under any conditions. If you take any condition, the potential difference between the two electrodes is called as cell potential. Whereas EMF is the potential difference between two electrodes in the cell when no current is drawn through the circuit. Here you should remember, while considering EMF, no current is drawn through the circuit, that we call it as EMF of the cell. Next one is cell potential is always less than EMF, whereas EMF is the maximum voltage obtained from the cell. So always cell potential is less than EMF, but for calculation purpose we take cell potential and EMF as same. But there is a difference between cell potential and EMF, and cell potential is always less than EMF, but for the calculation purpose we take both cell potential and EMF as same thing. For a Daniell cell, we are writing the cell reaction as Zn bar Zn2 plus, which is oxidation, and it is taking place at anode, which we have to write it at left side, and right side we should write reduction, which is taking place at cathode Cu2 plus, it undergoes reduction into Cu, and we have to write salt bridge also. This is the cell representation of Daniell cell. For this, how to calculate the cell potential or E cell? E cell is equals to E right side, electrode potential of right side electrode minus electrode potential of left side electrode. So how to write this one? E cell is equals to E Cu2 plus 2 Cu minus, that is E Zn2 plus 2 Zn. So this is how we are writing the cell potential for the Daniell cell. Problems on standard EMF. Calculate the standard EMF of the following. First one, cell formed by copper and zinc. Second one, cell formed by zinc and magnesium. And cell formed by Cu and Ag. Here is the standard reduction potential of Cu2 plus 2 Cu, that is equals to plus 0.34 volt, and standard reduction potential value of Zn2 plus 2 Zn is minus 0.76 volt. Standard reduction potential value of Ag plus 2 Ag is plus 0.80 volt, and the standard reduction potential of Mg2 plus 2 Mg is minus 2.36 volt. This is the question. Here is the solution. For the first one, cell formed by copper and zinc. For copper and zinc, standard reduction potential values are given. E naught of cell can be calculated as E naught of cell is equals to E naught of cathode minus E naught of anode. So here for the copper and zinc cell, which should be taken as a cathode and which should be taken as an anode? For this, the one which is having higher reduction potential should be taken as a cathode, and the one which is having lower reduction potential is taken as anode. So here cathode is copper and anode is zinc. So E naught of cell is equals to E naught of Cu2 plus 2 Cu minus E naught of Zn2 plus 2 Zn. So here value we have to substitute, and E naught of Cu2 plus 2 Cu is 0.34 minus E naught of Zn2 plus 2 Zn is minus 0.76. So minus of minus 0.76. So answer is 1.10 volt. This is the cell potential or standard EMF of the cell formed by copper and zinc. Second one is cell formed by zinc and magnesium. The standard electrode potential values for Zn and magnesium is given, and the formula to calculate E naught of cell or standard EMF of the cell, E naught of cell is equals to E naught of cathode minus E naught of anode. Here which should be taken as a cathode and which should be taken as anode? By looking at the standard electrode potential, we can decide. So one which is having higher reduction potential is acting as a cathode, and the one which is having lower reduction potential is acting as anode. So here zinc is acting as a cathode, so that's why E naught of cell is equals to E naught of Zn2 plus 2 Zn minus, here anode is magnesium, so E naught of Mg2 plus 2 Mg. Substitute the values of electrode potential, standard electrode potential of zinc and magnesium. Zinc it is having minus 0.76 and magnesium it is having minus 2.36. So calculate this one, you will be getting answer as 1.6 volt. This is the standard EMF of the cell which is formed by zinc and magnesium. Third one is cell formed by copper and Ag. The standard electrode potential values are given. E naught of cell or standard EMF of the cell is equals to E naught of cathode minus E naught of anode. Here which is acting as a cathode and which is acting as an anode? The one which is having higher electrode potential is acting as a cathode, and the one which is having lower reduction potential is acting as anode. In this particular case, Ag is having higher electrode potential, so it is acting as a cathode, and the copper which is having lower reduction potential, so it is acting as anode. So E naught of Ag plus 2 Ag minus E naught of Cu2 plus 2 Cu, we have to take it. So substitute the value 0.80 minus 0.34, and you will be getting the answer as 0.46 volt. This is the standard EMF of the cell formed by copper and Ag.